Hi, I'm John Hoford. This is Nicolas. We work on constraint layout, and we also do design studio work. But today we're going to talk to you about Constraint Layout 2.0, a sneak peek. We're basically going to give you a little bit of a heads up as to what we're doing, and you'll understand why.
But first, we are going to talk a little bit about 1.1 that's been, coming together after a lot of hard work. And in fact, it's released today, so if you update your dependencies, you should be able to use it. So I don't know how many of you are familiar with 1.1 and, particularly in comparison with 1.0. Essentially, we didn't add actually that many things. We added a couple of new constraints, a couple of new objects for helping you creating your layout. But a lot of the work has been spent on performances, the new optimizer, and of course a lot of bug fixes. Essentially, you get a system that's a lot more flexible and powerful than before. So what did we add? We added the ability of setting constraints on dimensions. So you can set up, for example, your widget dimension as percentage of your parent. You can set up min-max on match constraints. You can constrain a wrap element as well. We have new constraints like the circular constraints. And in general, the chain construct that we added in 1.0 was working, but in a relatively simple situation. Now it works all the time with all the complex situation. If you are using ratio, match constraint, etc., etc., everything works pretty well. The circular constraint essentially allows you to position a widget relative to another one with an angle. It's somewhat limited use case, as you can tell, but it's a cute example. But fundamentally, you can use that for circular menus, or I've seen people using it, for example, to position an arrow of some kind to another element. So it's pretty cute. The helper object is actually something we'll talk a little more in this talk. But we added barriers, and barriers is very, very powerful. That's actually the main reason why we call that 1.1 is because I really, think that barriers should have been part of 1.0. And we got a couple more, like the groups and placeholders. But essentially, barriers is a way of setting. If I look at a group of widgets, a set of widgets, how can I find what's the minimum or the maximum of, for example, the rightmost edge of this set of widgets. And of course, you can then constrain other widgets to that barrier. That allows you to build a lot more flexible layouts that react to change. A quick example. Imagine that you have those three text views on the left, and really what you want is to set up. So you have those three elements like that, and you want to set up that image view on the right. You want to set it up at the right of the set of those widgets, regardless of who is the widest. So, in that situation, the widest is going to be the first one, but essentially, if I change that, and here the widest becomes the last one, I want everything to reflow correctly. And that's what barriers allows you to do. So you set up a barrier on those three elements, and you set up that image view onto that barrier. Groups, we thought that it would be useful to have a kind of a shortcut when you want to have a set of objects that you want to set the visibility, which is kind of useful for constraint layout, because constraint layout does a lot of automatic work. When you set the visibility on elements, you can specify, for instance, like my element is marked as gone, but the layout is going to reflow correctly. So you could, of course, do that programmatically, but with group, you can just essentially, you can think about it as tagging all your widgets that are in that group, and you can simply call set visibility on the group, and it will apply. So it's nice, and we'll extend it a little bit in 2.0. But fundamentally, you can look at this example where I have those text view 2s and 3. I can mark them into a group. If I set invisible into that group, they will all be marked as invisible as well. If I mark them as gone, they get gone, but the layout will overflow. And the final stuff we did add was this placeholder concept, where essentially you can have a placeholder at a specific position in your layout that you just manipulate like a normal view. And that allows you to set the content of that placeholder. We essentially remove the element you're pointing to that's elsewhere in your layout, put it at the placeholder position, and map the original position kind of like as gone. So useful for this kind of, I want to move my stuff around like that. The optimizer, as I said, we spent a lot of time on this one. We did have an optimizer in 1.0, but that was kind of like a much more simpler version of that one. What we can do is we try to resolve as much as we can before running into the linear equation solver, because the linear equation solver, not surprisingly, is not the cheapest one to execute. And we know of the concept of having multiple optimization passes that you can kind of pick and choose. There's a couple ones that are really interesting that right now in 1.1 are marked as experimental. They actually should work pretty well, but it's definitely something I would encourage you to try. If you have issues, please tell us, because that's something I'd like to pass them as the standard ones in 2.0. So how do you use the optimizer? Well, essentially, you just add an attribute in your constraint layout. If you use standard, which actually is the default, you'll have the direct and the barriers, and that's it. You can also set none if you want no optimization. So if you have some issues with your layout and you are suspecting that maybe we screwed up something in the optimizer, use none and you'll see. Otherwise, it's just a mask, so you can decide what are the ones you want or not. And as I said, the chains and dimensions are, experimental, but they should work pretty well. Dimensions in particular is very interesting, because what we try to do, one of the costly things when you lay out something is measuring those elements, and it's really costly for text view and stuff like that. Sadly, in constraint layouts, there is this match constraint concept, like the 0dp stuff, that allows you to spread your elements, for example, in between two other elements. The way constraint layout works right now, when you use 0dp, it double measure. It's actually doing the same as what linear layout does in that same situation, but still, even though it's still not great. So with dimension, what we are trying to do is we pre-solve part of the graph of constraint, and in many situations we are able to avoid a double measure. So that depending on your layout, that can be really a big win. So please give it a try, and if you have any issues, report it. We'll fix it. The way it works overall is that you get your layout expresses constraints, we take those constraints, we run them through the optimizer, we try to resolve as much as we can in the optimizer, essentially everything that is non-ambiguous. We then run the measures, possibly a lot less than usual, and whatever is left over, we run it through the solver. So that's kind of gives us the best of both worlds, where we got the power of having an equation solver that can really gives us a result on ambiguous situations, but at the same time, when you have situations that are actually pretty straightforward, we just solve them directly. How does it work roughly? You can imagine a situation like that, right? You have a widget. That widget is constrained to something else on the left here. If you happen to know the position of that stuff you are connected to, well, you can directly, infer the position of the widget. And of course, it will then, propagate through the constraint graph. So if you have a second widget that constrains directly like that to widget A, we can also solve it. So you can think about all those constraints you express as a gigantic graph, and essentially, we can solve a large part of this graph depending on your layout. So you still end up, in the best situation, we solve everything into the optimizer, and we don't even run the linear equation solver. In some situations, we still have to run the equation solver, but it's still a huge win because we have a much more reduced graph of constraints. And now,
yeah. So we're now starting the journey of 2.0. It's going to be a little bit big, so you'll have to bear with us on it. But first, what is the problem we're trying to address here? And it's not making coffee, but if enough of you all ask, maybe. But why are we trying to do this? People are getting more and more demanding to do more sophisticated layouts. People want to have things that are animated, flying in, fancy decorations on things. And as developers, it becomes harder and harder to keep productive and still build all these things. So we need sort of better tools. We need to essentially provide a system and a pattern by which you can evolve your tool chain, and essentially you need help to provide it. And that's kind of what we're trying to figure out how to do. How do we make it so that it's easier for you to get the interactions, the sort of higher level interactions that you want. And so what you'll see here today is some of the things and the kind of a pattern we're going to evolve in. We're essentially trying to expand your vocabulary, give you some new concepts in there, focus on making it toolable. So the concept is if I give you something that you can build a new behavior, you should be able to use that new behavior inside of the GUI builder. So you should be able to drag and drop it into the system, things like that. And so you'll see how we evolve it as we go on with this, and you'll kind of get the picture. But essentially trying to provide you with a sort of a comprehensive pattern where someone can build tools, or you can find sort of new behaviors off the web, and then you just incorporate them, and it's part of the palette. You can drag it in. It's part of the behaviors of the system. So
we think we can achieve that by expanding on this concept of helpers. So if you remember on constraint layouts, we, contrary to a lot of layouts, we have some stuff that actually are part of your view hierarchy somehow, but are actually not part of the view hierarchy. And I'm talking about guidelines, for instance, where you can set up a guideline object that's really handy. You can define your UI just like that. Set up a guideline. It's great because it's a concept that your designers are used to, and you can set up your layout in relation to those guidelines. But the very interesting thing is that a guideline actually is not an object that will be shown on screen. It's just an object that we put there for you to set up your UI. So that's a helper. Another type of helper is the barriers that we just talked about before. It's the same idea. So we identified a couple of different scenarios where helpers can be pretty handy. Essentially, we have helpers that will help you create your layout. Barriers, for example. You have helpers that may want to do stuff after your layout is done. And finally, you may have some helpers that will do some stuff rendering-wise. So the concept of helper here is that it should be something that keeps reference to views. It's just essentially, it's a way of setting a collection, right? And then your helpers has a list of views that it can work with. We still want to keep everything flat as a hierarchy. And we expanded upon that with constraint layout. The reason why you want it flat, there is performance, that's one of them. But there is a lot of other situations where having a flat hierarchy is very handy, specifically with animations, and we'll cover a couple of other cases. So idea is that we got views, they are referenced by helpers, and fundamentally, because a view can be referenced by multiple helpers, you could think about it instead as a way of tagging your view. And because a helper can have a behavior, you essentially can tag your views with behaviors. That's the reason why people are using tags on Gmail or whatever versus having a very strict hierarchical system. Having tags allows you to essentially mix and match stuff rather than having to create the entire set of possibilities. So the API for helpers is something we'll expose in ConstraintLayout 2. You'll get an access of the list of views. You'll have pre and post layout callbacks. They're actually views, so you got all the benefits of the view framework. You can still use everything that a normal view would do. In fact, that's actually what we are using in groups and barriers. It's just something we decided to not expose at the time because we were not quite sure about the API. Now we're a little more confident, so we will expose that in 2.0. An example of a helper we'll have in 2.0 is collection, which essentially is probably what group should have been, where you will be able to programmatically call functions like visibility, alpha, rotation, etc. And this will simply apply that same call on that collection of objects. So that would be very handy if you just want to keep a collection of objects and you want to apply an operation on it. You don't have to manage it in code. You set up your collection, and in code you just call one, and that's it. So, I talked about like the different type of helpers that we could have. One of them is decorators, and we touched a little bit about that with some past presentation with ConstraintLayout 1.1, but we really expanded this concept with ConstraintLayout 2.0. Again, decorators is going to reference views. And the idea here is that you could build some kind of graphical representation or special effects or anything like that, depending on those views. So that could be depending, for instance, on the position of those views, the bounds of those views. Here's a quick example. You got this thing called a Metaballs Decorator. You just need to get on the post layout, so ConstraintLayout does the layout of the elements, and post layout, the Metaballs Decorator is going to look up at those views and then do something in the on-draw. So the idea here is that if you think about your usual canvas, you may want to have image views, and essentially the decorator is going to be in charge of drawing the background of those image views. Normally you should look at me and say that's super weird because image views, they know to draw their background, so what are you talking about? Well, one thing you can do with that is to draw that background in relation to those other objects, so you can have a pretty cool effect like that. And that's something that normally would be pretty difficult to do with the normal way of thinking about views. But with a decorator like that, where you keep track of the views reference, you could do this kind of special effects. And you can see here, if I turn down the debugs, I still have my views, so I still have all the benefits of having real views, and I just manipulate them, and everything is redrawn like that.
So one of the first new decorators that are going to be in 2.2 is something we call layer. And essentially it has an API on it which can manipulate the collection of views post layout. So it'll support the transform operations like like scale X, scale Y, etc. It also is aware of the bounds of the object, and its bounds are going to be associated with the bounds of the collection of objects, plus you can add margin. So first, kind of simply, a good example is, let's say you take that bounds and you want to draw something on it. We define a shape, in this case it's a sort of rounded rectangle. And on the layer object, you actually just insert the background of it. So in your GUI builder, you can insert a layer object and now say this is set its bounds, set its background to this, and essentially you get that. The 6 of them, but since it can operate the transforms, and this is not actual layers with clipping, you can actually animate the thing. So what would happen is you can set transforms on the thing, and it can just do whatever it wants, right? I mean, as silly as this demo is, notice the bounds meant nothing to it. It still is drawing the rectangle underneath it. Now it's a silly demo in that sense, but you can kind of see the power of managing it separately. And it's a completely separate object. You can drag it, you could build one yourself. and you can put it in. You can build a subclass of it, and we'll see some more examples of that. So kind of one of the examples, this example, how did it do all that translation is, as you'll see here, I basically find the layer object, and I do scale X and scale Y and translate, and I do some sine waves and stuff to make it just, fly around the screen goofily, but you get the picture. It's pretty straightforward to manipulate an object like that. And that's most of the code besides, something to drive it. So another example that's pretty straightforward to see you might want is, let's say you like to have your objects fly in for introduction of a new activity. Well, you can write a fly-in object. You put it into your list, and you attach all the views, and that can even be done with drag and drop, right? You can just drag the views that are going to be flown into the system, and you get a fly-in effect more or less for free. And to show you a little bit of what's happening underneath is it's going to essentially gather up all the views, calculate a centra of the views, but you can also set the center, the pivot point. And then on updates, post layout, it will actually manipulate all the views and position them with scale X, scale Y appropriately. Mathematically, it'll solve the problem. And then it just has an operator fly in. And then all we do is object animator in the pre-layout. We're looking for when the container comes in for real. So what it means, when the container came in, it means you're now on the screen. So you can start your animation. And that's kind of all there is in that code, that code set. And in the XML, you just set the list of buttons, essentially. And in this particular case, there's a background that's being set to red, which is the old surface. As a bonus, you see how we calculate the center of it. So it's pretty much just calculating the max of all of the objects. But this is not a very complex object, really. It's relatively simple to imagine subclass of the default one, but it's so useful for certain kinds of effects that we're going to have it. Now another example is you want to do some kind of weird circular reveal like this. It's kind of common now in Android to have circular reveals. So you can imagine what the helper would look like, a circular reveal helper, and you say, oh, I put the lake there, set it to lake as background. And how does that work internally? Basically, on post layout, I create a circular reveal animator. So I'm building an object that is now kind of reusable inside of your applications. Inside, so it's you can imagine if you have a large team, you can imagine having one person who gets good at this and is providing these effects to the other people in the team. Or if you're a small team, you might find these things on the web and you're just like, oh, I grab it and I put it in and I use it. That's one of the tools I use.
So I think that for the decorators, the key here is that we have behaviors. Those behaviors, you could write them yourself. You may be able to reuse a third-party library that implement some of them. This behavior is all encapsulated. You can declaratively apply them to views, and it's all going to be tied with the layout editor as well. So for you, it's just a matter of just drag and drop, apply them, and that's it. And because you can apply multiple behaviors on the same object, you can come up with really pretty interesting combinations. And that brings us to virtual layouts, right? In the same way that we got those decorators, we can have layouts. So, we keep a reference of those views that you indicate. We still want to keep the flat hierarchy. And, we implemented a couple in ConstraintLayout 2. We might implement more as we go along. The, easy one is kind of like a linear layout. essentially what it does, it creates an horizontal or vertical chain, and you use it like a normal view. You can constrain that linear object, you indicate its orientation, and it contains the referenced element. And you get that, which is very, very similar to what you get with linear layout. The difference here is that the normal semantics of chains still apply. So you could have all the typical behaviors with packed chains and spread inside and all of that will come for free. But because it's still a view, you can very easily set up other widgets being in relation to that one. So if I set that text view, for instance, I can make it relative to that linear object as well. The other thing is that, of course, it saves you time to create those chains, and it makes it also easy to add elements to that chain at runtime, because now it kind of behaves a little bit like a container. The one that you might be more interested in is flow. And essentially, we are trying here to add Flexbox layout-like semantics to it. Otherwise, all the rest is still the same. It's still flat, and you use it exactly the same way. You reference your IDs, and if I reference, if I use an image view here, I can. That's the other thing that you could do as well with the other one with linear, is that you can also reference directly the elements that are in that layout. So if I want to have this image, for instance, to be on the left of button 6, on the left side of button 6, but below this button 8, that still works, because we don't have a hierarchy really in terms of view hierarchy. So you can still reference the inside element, which can be pretty nice. So here's a quick example running on Chrome OS actually. And you see that when I resize the window, everything will correctly position itself.
Layout management. So one of the things that you've seen before, and you've seen it on several examples, where you can sort of take two layouts and use them with constraint sets and switch back and forth between them. It's popular enough that we wanted to add a little bit more to that, and also support some other behaviors that you might not be that are a little bit difficult, especially within the context of now having resizable applications, because they're no longer just on phones, and even on phones you can resize the size of a view if you absorb the handling. So how does it work? Essentially, now you create another XML file which references back to the layouts that you want, and by saying, I have two states in this particular case, a small state and a large state, and this is the layout for it. Is the constraint set actually. So what's going to happen is it's going to pull from that layout all the constraints from it, like if you did a constraint set clone, and then it's going to apply it to another layout. You'll see. So then in onCreate, you can actually go and inflate that. You see the set layout description, and you give it the actual layout, the XML file. And that's going to now tell the system, the constraint layout, you have two states in you. And one state is this, and one state is that. So the constraint layout now knows about two states that it could be in. Then to change states, you simply say constraint layout set state, and it'll know to change the state. Now that's really useful in situations where you have I have with or without the person's photograph. I have a user interface without the person's photo, with the person's photo. Well, you just have the same layout. You have two states for it. Or you have a bigger image in one and a smaller image with more text in it. So one of the other things you can do with this new state description is set for a single state multiple layouts based on size. Now that's kind of strange. Why would you care about it? Well, if I have an object that's I can resize it on my phone, or in the case of Chromebooks, I can change the size of the application. You might want to rearrange your layouts based on that. And again, you pass that state, but now you pass in the width and the height of the object. And what will happen there is it'll naturally switch to the next layout, right? No inflation is happening during this piece. It's smooth. No objects. All your references to the objects will stick around because they're just being moved around on the screen. And essentially, you've kind of decoupled one of those things that you tend to do with your systems. Now, if you wanted to get fancy, you can listen now to a pre-layout change and post-layout change on the constraint layout. And what that'll allow you to do is use Transition Manager. So if you do something like that, and this is a kind of a simplistic example, you see it's resizing, but when you resize it, it naturally flows in its resize. It's not going to be clunky. So it looks like a very intelligent resize at that point. And we're going to try and evolve this a little bit more in the future as we progress. So key here is it's centralizing multiple layouts to a single XML and say, this is all my layouts for this particular screen. It's sort of easy to set up and initialize, and it has the size qualifiers.
And one of the things that we found that people ended up doing is, using constraint layout in a programmatic way. Turned out that yes, declarative XML is great. Some people still want to do stuff at runtime, strangely enough. So the current way that people do it right now, we introduce constraint set. And constraint set allows you to capture the entire state of a constraint layout, all the constraints that are being used in that layout. So, of course, we could modify a constraint set, but that's kind of like the only way right now that you could do a modification on the fly, which is not great because that means I'm creating a constraint set, modifying it, then reapplying it all together to the constraint layout. It's a little heavy, and it may not be like the best way of doing that. So we come up with a slightly different API to directly modify essentially the layout params or the constraints, and exactly what I've just said. And essentially you can easily create that, and that will directly give you a much nicer API to work with to set up constraints. So you can see like in the slides, pretty straightforward. You create a constraints object, apply, and just call those different functions on it, and you can just end up with apply. It will apply it, done. Couple of other examples. You can set like a center, set the bias, etc., etc. It's pretty straightforward. There's of course a ton of things. I'm not going through all of them, but yeah, it is pretty convenient. Particularly if you are using constraint layout to create your own custom widgets, where you may want to take the advantage of having a constraint system, use that as your vocabulary to express how your layout or your view is going to be set up. But now you can, if you have to do it programmatically, you should be able to do it in a much nicer way. And that kind of concludes the Constraint Layout 2 summary for now, at least. So essentially, we are going to have virtual layouts. So you get the advantage of easier setup for your layout. At the same time, keeping the advantages of being flat, keeping the advantages of the resize, the animation, and etc. We really think that this concept of the helpers object is going to be really handy, particularly because it integrates so well with the tools. And we'll have a few more things at Google I/O. So hopefully you'll attend our talk or not. Look at it on YouTube, yeah. And of course we'll be here. So if you have any other questions or suggestions, feedback, bug reports, please do contact us. We really happily do that.
Yes. Okay. Thanks.